Calc AB, Section 6.1, Antiderivatives, Differential Equations, and Slope Fields, Notes, page 1. We're looking at the difference between this situation and this situation, or this expression and this one. This first one you should be familiar with. This has bounds here. This is a definite integral. And that definite integral finds the area between a curve and the x-axis from A to B. This one down here without the bounds is called an indefinite integral. And an indefinite integral is merely going backwards from a derivative to a function. Plugging through some examples here. We're just thinking, we're going to do this very intuitively, going backwards. That was my cell phone, sorry about that. Going backwards from 3x squared, from this derivative to the function. We'll do an antiderivative here. And x cubed will give us 3x squared. Don't forget now we have that constant here, plus c. Looking at this next one, and we think, what's the antiderivative of negative x to the negative 3? That means what thing, when you take the derivative of it, gives you negative x to the negative 3. One procedure to go through with this is to add 1 to the exponent, which would give us x to the negative 2. Then take the coefficient that was out there and divide by the new exponent. That gives us a positive 1/2. On this x, add 1 to the exponent. Divide by the new exponent. So that's 1 divided by 2/2. And the antiderivative of a negative 1, negative x, plus a c. Looking at this one should bring back some memories from doing derivatives. Whenever we saw radicals, we always rewrote them with rational or fractional exponents. So we can see this as x to the 1/3 plus x to the negative 1/3 times dx. Using this little trick now about adding to the exponent. It's not really a trick, it is a pattern though. Add 1 to the exponent, that's x to the 4/3. Take the coefficient there, which was 1, and divide by the new exponent. That gives us a 3/4 out here. For this next one, add 1 to the exponent. That's going to make that x to the 2/3. Divide by the new exponent, puts a 3/2 out here. Don't forget that plus c. Now, what's nice about doing this is you can always do a derivative on the answer and make sure it gives you back what you started with. And if we think about that, 4/3 coming down here times this 3/4, that's 1. Subtract 1 from the exponent, there's that 1/3. Pull this 2/3 down in front and multiply. Gives us a coefficient of 1. Subtract 1 from the exponent, negative 1/3. And then the derivative of any constant is 0. All right, let's look at this one down here. Let's throw some trig in here. We have this leading multiple out in front of this sine x. That 3 is going to come down. And then we think what thing, when you take the derivative of it, gives you sine. Well, that's negative cosine. So we have negative 3 cosine x. And then this piece out here, minus Again, the antiderivative of a sine is going to be that negative cosine, which is going to turn this to plus cosine 3x plus that constant. I'm putting that out here. We do have some adjusting here to do on this one, because if we were to do the derivative of this, that derivative would give us negative sine 3x, but then times a 3. I don't want that 3 out here, out in front. I want a coefficient of a 1 out here. So that means that we're going to have to put a 1/3 out here, so that now when we do the derivative of that 1/3 cosine 3x, we get 1/3 sine 3x times 3. The 3's and the third multiply or divide out, and we're left with sine 3x. Looking at this piece over here, oh, we have 3 separate pieces. We have a rational function, we have a trig, and we have an exponential. All right, let's deal with this rational first. We have a 1 over a linear piece. So what thing, when you take the derivative of it, gives you a 1 over situation? That's a natural log. Make sure you use the absolute value here, because we have to remember from pre-calculus, you can only take the natural log of a positive number. So the absolute value guarantees that this is a positive number. The antiderivative of a sine 5x, negative cosine 5x. But then we got to deal with that times the derivative of 5, so that'll put a 1/5 out here. And then the antiderivative of this e to the negative 2x. Well, we need that e to the negative 2x, but then remember, when we do that derivative, it's going to be e to the negative 2x times the derivative up here, oops, just a negative 2, but we want this coefficient out here to be a negative, so we're going to need plus half out here. So now if that half was down here, when we did the derivative of this, 1/2 e to the negative 2x times the negative 2, when you simplified, that would give you a negative e to the negative 2x. And right now we are doing this very intuitively. This next one, sine squared dx, that integral, if you think back to all the trig functions, all 6 trig functions and their derivatives, nothing comes up with sine squared. So you are going to have to remember some pre-calculus. Do you remember this identity? Cosine 2 theta is 1 minus 2 sine squared theta. Let's solve for sine squared. So let me subtract this 1. Negative 1 plus cosine 2 theta is negative 2 sine squared theta. Divide out the negative 2, gives us positive 1/2 minus 1/2 cosine 2 theta equals sine squared theta. Now take this statement right here and replace out sine squared. So this is coming down here, and I'm going to replace out sine squared with this mess right here. So we end up having the integral of 1/2 minus 1/2 cosine 2x, because we're in x's now, dx. Now do an antiderivative, and the antiderivative of a half x, minus, all right, I'm going to leave this half alone for a minute, and we're going to do the antiderivative of a cosine 2x, that's sine 2x, plus a constant out here, plus a c. Oh, shoot, I see that back on this one right here, I forgot that plus c. I was so worried about getting this half out here, I forgot that plus c. So go ahead back and plug that back in. All right, now come back down here to this one, and let's finish up this coefficient out here for sine 2x. The derivative on this one would have been derivative of sine cosine 2x times 2. So I need to put something out here so that when we multiply it by 2, we get a half. That's got to be 1/4. That's that answer right there. Some more examples on page 2. Please join me.